everyone. Welcome to the first video of the IGCSE Chemistry series. In this video, we're going to take a look at the way that particles are arranged in solids, liquids, and gases, and the attractive forces which exist between them. And the purpose of this video is really just to help you think about things in terms of particles. The syllabus requires you to be able to distinguish between a solid, liquid, and gas. In terms of shape and volume, solids will have a fixed volume and a fixed shape. Liquids will have a fixed volume, but it doesn't have a definite shape. Whatever container that you put your liquid into, it will change into the shape of that container. Gases do not have definite shape or definite volume. Gases can either expand or contract. Solids have high density and liquids have a medium density, meaning that liquids have lower density than solids and gases have the lowest density. We're going to use ice, water, and steam as our example. In solids such as ice, the particles are packed closely together in a regular lattice structure. You can try to understand the word lattice as a regular, neatly arranged particles. In liquids, the particles are randomly arranged. Although they are randomly arranged, we can see that some of the particles are still touching each other here. In gas, the particles are randomly arranged, but the difference between the random arrangement in liquids and in gases is that the gas particles are not touching each other at all. In solids, the particles can vibrate in fixed positions. That's the only movement that solid particles can do. In liquids, the particles, just like in water, they can move and slide past each other. That's why water is able to flow, and if you put a spoon in a cup of water, you can still move around the spoon. In gas, all of these particles are moving randomly at high speed in different directions. In terms of energy, solids are known to have the lowest energy, liquids will have a greater energy than solids, and gases will have the highest energy. Reason why is because you need to apply heat energy to the solid particles in order for it to become liquid particles, and you need to heat the liquid particles further to turn them into gas. So meaning that gases will have the highest energy and solids will have the lowest energy. Integral version of states of matter, or you can simply call this changes in states of matter. We will learn some of the terminologies first. The red line here represents heating, and the blue lines represent taking away the heat or cooling down. When solids are heated, they turn into a liquid. When a liquid changes into a gas, it's called evaporation or boiling. We'll take a look at what the difference is later. When gases change into a liquid, it's called condensation, and when liquid turns into solid, it's called freezing. When a solid changes into a gas without the liquid phase, it's called sublimation. When a gas changes into a solid without the liquid phase, it's called deposition. Solids will have the lowest energy because only when heat energy is applied to solid, it will become a liquid, and only when we apply heat energy to a liquid, it will become a gas. That's why gases will have the highest energy and solids will have the lowest energy. Similarly, if a gas is to become a liquid, it will be known as losing energy, and when a liquid were to turn into a solid, it would also be losing energy. Evaporation and boiling is the change in state of a liquid to a gas. but they have many differences. On the left side, we can see a pot of water boiling. On the right side, we can see a puddle of water here. Both of the water in these cases will change their states from liquid into a gas. Boiling is a very rapid process and it will take a very short time. However, a puddle caused by the rain, the time taken for it to evaporate will be slower and it will take a longer time. Boiling can only happen at specific temperatures. For example, water can only boil at 100 degrees Celsius. Evaporation, on the other hand, can occur at any given temperature. In boiling, we'll be able to see bubbles forming, but in evaporation, we won't see any bubbles forming at all. And boiling is a process that occurs throughout the liquid. When heat energy is applied to the water particles, every water particle will gain the heat energy throughout the liquid, and that's why the process will take a very short time. However, evaporation only takes place on the surface, and that's why it is a much slower process and it's a longer time. For boiling to take place, we require an external heat source, such as a heat stove, but for evaporation, it's a natural process and it requires very little to no energy at all. At IGCSE, it is expected of you to know what is kinetic particle theory, and you have to use the theory to explain what happens in terms of particles when melting takes place, boiling takes place, freezing takes place, etc. When substances are heated, the particles will absorb the thermal energy and change it into kinetic energy. Kinetic energy simply means the energy which you produce because of movement or motion. When solid particles are heated, all of the particles will gain heat energy. Then the particles will start to vibrate in fixed position. And when the particles have gained enough heat energy, the structure will break and it will form a liquid here. The temperature at which a solid melts into a liquid is called the melting point. Upon further heating, the liquid particles gain energy. When liquids are heated, the liquid particles will gain energy and they will start to move around. And when the liquid particles have gained enough energy, the intermolecular forces will break. And that is when the liquids will evaporate or boil. You heard of a terminology that you're not familiar with, which is called the intermolecular force. What does it actually mean? Let's imagine this black circle as a water molecule. So now I have two water molecules here, and between them there is an invisible attractive force that holds them together so that they can flow around like a liquid. That attractive force is called the intermolecular attractive force. Inter meaning between and molecular meaning molecules. So the attractive force between two molecules are therefore called intermolecular attractive force. And because of heating, that intermolecular force will start to break away. That's when the liquid will become a gas and they will start to move away at different directions at different speeds, just like we're seeing in the gas diagram here. That's it for today. Leave a like if it was helpful to you, and I'll see you all in the next video. Bye bye.